Now this is our task 2, and we have to use Newton-Raphson's method to try to find a zero of the function here. The function given to us is 1/3 x to the power 5 minus 3x squared plus 10, and we have to first use a starting value x0 is equal to 1 and perform 5 iterations and then come to a conclusion for it. So we start working on it now. Let me write the function again. The function is equal to 1/3 x to the power 5 minus 3x squared plus 10. And okay, so this one here, now we need, for the Newton-Raphson's method, we need the derivative of this function. So let's find out the derivative of it. So the first derivative of it will be equal to, I hope you know how to find out the derivative already. So anyhow, I'll teach for this one here. So it will be 1/3 multiplied to the power of x, which is 5, and x to the power 5 minus 1, minus we have 3 times to the power of x, which is 2, and x to the power 2 minus 1. And for the, let's write, so plus 10 here, x is to the power 0, so it will be 10 to the power 0, and x is to the power 0 minus 1. Now here this will be 5 over 3 x to the power 4 minus 6 x to the power 2 minus 1 is 1, and here this is 10 to the power 2 times 0 is 0, and 0 times anything is 0, so we don't need to write that. So this is the derivative of f(x). Now for the Newton-Raphson's method, the formula is x, I'm not sure in class we used n or k, so let's write here k plus 1 is equal to x to the xk minus the function value, which is f of xk, divided by f dash xk. And now, so here this is the main formula for the Newton-Raphson's method. So we'll replace this with our function now. So we have xk plus 1 is equal to xk minus the function, which is 1/3 x to the power 5 minus 3x squared plus 10, divided by the derivative of the function, which is 5 over 3 x to the power 4 minus 6x. So we could put a k to all of these x's here because their values will change. So the first one for us, which is x0, is given to us in the question, which is, for the first one, is 1. So let's take x0 is equal to 1 now and find out x1. So for x1 now, let's do it here. So for here, for the x to be 1, will be k will be the value 0 here. So 0 plus 1 will be 1. So x1 is equal to x, the k is 0, so it will be 0 here, x0 minus here 1/3 x0 to the power 5 minus 3 times x0 squared plus 10, divided by 5 over 3 x0 to the power 4, and then you have here minus 6 times x0. So if you calculate it, you have x0 is 1 minus 1/3 x, okay, not x here, but times 1 to the power 5 minus 3 times 1 to the power squared plus 10 divided by 5/3 times 1 to the power 4 minus 6 times 1, and this gives us the value 2.692307. Okay, so that's x1 value for us. Let's write it down. Do we have a decimal point to take care of here? No. So we could write all the decimal places, or you could just make it however you like. So here I'll take all decimal places, which is 2.692307. And now for x2, of course, for the positions here where it was x0, now it will be x2 here instead of 1, and it will be x1 here, and all the x0s will turn to 1, and we'll replace the value 2.692307. So this becomes really lengthy calculation, so we don't need to do that. What we'll do is, in your calculator, save this answer, or you can say this will be as in your calculator saved as, it will be saved as answer. Now in the answer button this value is saved already, so now in your calculator you can just, for x2, press write answer minus 1/3 times answer to the power 5 minus 3 times answer squared plus 10 divided by 5 divided by 3 times answer to the power 4 minus 6 times answer, and this will give you the value for x2. And if you click on it again with the equal to sign, then it will give you the value for x3, and so on. You don't have to keep typing this again and again if you type it one time. Okay, now for x2 we have the value 2.196517, and for x3 we have the value 1.705858605. So we have to do 5 iterations according to the question. I am checking again. Okay, yeah, it's 5 iterations. So here now we have x3, x4 will be equal to 0.1366800517, and for x5 it will be equal to 12.270852234. So what would you conclude? What is your conclusion when you see the values of the x's? What would be our conclusion here? So we see that it's not converging to a value. It was 1, then it went to 2, and then it was 2, and then it came down to 1 again, then it went to 0, and then it went to 12. So it's not converging, but it's diverging. So our conclusion is that the function is diverging, or we can say there is divergence in the function when our starting value is 1. Now let's see this in a graph, how it looks like. So okay, so here now let's say I'll just, the first line here, that is at x is equal to 1, So here, this value here is x is equal to 1, and then we draw a tangent here, and once we draw the tangent we come to this value here. I'm not sure if you can see. So if you draw the tangent from here, which is this our value, sorry, this one here, okay, yeah, this value here. So you have one point, the x0 is equal to 1. So when we draw a tangent to this value here, we cross the y-axis, or sorry, the x-axis at 2.692. So if you see our first value that we have is 2.692 here, and we have 307. Those are the, if we did not do it to 3 decimal places, but they're showing in the graph as 3 decimal places here. So we have here 2.692 where it's crossing the x-axis. Now from here we'll go back up to the graph, and wherever we reach the graph we'll draw a tangent from there. So let's look at the graph now, and let's look at the second tangent. So here now we're crossing it at okay. So we're crossing somewhere very high, for which I'm not being able to see it. And from wherever we're crossing, we draw the second tangent here, and that tangent crosses the y-axis, sorry, x-axis at here, which is 2.197. and if you look at our work here, we have the next one is 2.1965. so here we have in the graph the value is 2.19, yeah, so 197, which is very close to what we have in the tab. Here 2.196, yeah. So now from here again you go up in the graph from this point, you again go up, and wherever you're touching the graph here, draw a tangent from there again, and that tangent, it's not very clear. So from where you're drawing the tangent again, and that tangent is crossing the x-axis at this point here, which is 1.706, which is our third value here, which is 1.706 if you round it up to the third decimal place. And now that's the value here too. So once we are here again, we go up in the graph, sorry, so we go up in the graph again, and we draw the next tangent, which is here. So we reach here and we draw the tangent here again, and that takes us on the x-axis at the value 0.137, which is our next value. If you see here in our answer, so we have here 0.136, here 0.137 rounded up to third decimal place. So as you can see, the graph, it's diverging, it's not converging, but the tangents are diverging, and that's something I can show you. Like, it's not converging to a place but diverging from the original position when x is equal to 1. Okay, now let's work for x is equal to 2. So okay, so this is task 2 continuation. And for now we have x0 is equal to -1, and as we have seen here previously, we'll put in the same formula. So x1, if you want to calculate, it will be -1 minus 1/3 times -1 to the power 5. Please do not forget the brackets, because otherwise you'll get a wrong answer if you have a negative number. Minus 3 times -1 squared plus 10 divided by 5/3 times -1 to the power 4 minus 6 times -1. So here, if you want to use the answer key of your calculator also, it's better you put it inside the bracket. Okay, so now this will give us the value of x1 as -1.8695655217. So that's the value for x1. Let's write it down here. So we have -1.8695655217, and so on. If you press in the calculator now with the answer key, just like I showed in the first part, you will get your values here in the x2 as -1.613088.171, and for x3 it will be -1.5440744696. For x4 you will get the value -1.539904.824, and for x5 you will get the value as -1.5399890588. So as you can see, we are almost converging to a value here. So here, after the 5th iteration, you can say that our conclusion for this function is, or let's write a sentence here maybe. Let's say the method converges here. Okay, so since the method converges, we can now say that we have got the 0 of the function here. So we are searching for the 0 of the function here, so we can say that the 0 is approximately at -1 point. If you're writing it to, let's say, 3 decimal places, so it would be -1.540. It's up to you, or you can just write the whole thing just like it is written here. So it's 539890588. Okay, now if you want to see this in the graph, how this one converges. We can show it to you. I can show it to you just a second. So we have to make it to -1 here, and that's how the graph looks now. So as you can see, the tangents, so that's like, this is the first tangent here, and it's crossing here at -1. So our x0 is -1 now, so at -1 it's crossing the function, and then we draw a tangent on it, and that makes it cross the x-axis at -1.87. So our first value is -1.87 here, and then we have, from here again we'll go down and touch the graph, and we'll draw the second tangent, which is the bluish purple color. So that's the second tangent. So from here, if you go down straight, you touch this point here, and from here when you go down to the x-axis, so you draw the tangent from -1.87 here. This one, this, I'm not sure if you can see, so it's this place here. So you draw the tangent from here, and when you draw the line back to the x-axis, you will get this point here, which is -1.613, and our second value was the same. Okay, I did a mistake here. I think I didn't show you the graph, so I'm sorry. So as you can see here, from here, the bluish purple color graph is the second tangent that we are starting from -1.87. This is the place when you come from the red tangent. When you go to touch the graph, you touch it down here, and that's the bluish purple tangent now, which if you go back to the x-axis, you touch it at -1.613. and now this is our second value, as you can see here, which is -1.613. and then we again touch the graph from this one here. We try to go to a point where it touches the graph again and draw the next tangent. So the next tangent is here, which is the blue color, and so it's touching at this place here, and then when it goes back to the graph, so we have -1.544. so we have already kind of reached the 0 of the function here. So that's already almost the 0 of the function, and -1.544 was our third value. If you see it here, that's -1.44. and then we can draw the next tangent here, which is orange color. Not sure if you can see it. Yeah, so that's coming and stopping at, so here is from where you drew the tangent. So this place is from where you start the tangent, and this is the -1.54 is the place. It's saying that the 0 is at this place here of this function. So it's very clear, and this one converges really fast with the Newton-Raphson's method to the 0 of the function, not like the other one which was diverging. So you can see the whole graph at once, and you can see that this is converging to the 0 of the function, which is here at -1.54, and that's what we have approximated it to also in our calculation. Thank you.